Okay. Okay. Good morning. Good morning, all. In previous classes, we have completed first unit and we have seen different image transforms. Now, the second unit is the title of second unit is image enhancement. We know the definition of image enhancement. The image enhancement means it improves the quality of the image. So you need to process the original image. So after processing, that image is called resultant image or processed image. If you see, if we compare this processed image with original image, definitely the quality of the image is improved after processing. So who can judge whether it is good or not, whether it is good or bad? Who can judge? So the judgment is given by again a human being only. So for the human perception, for the human point of view, human being point of view, suppose for one person that image, whatever the processed image, is looking like a good image, a good quality. The same image, if we see another person, his point of view or our point of view, it may be not good. Still, some modifications required in that image. He may feel like that. So here it is a subjective process. The image enhancement is a subjective process. So there is no any a prescribed procedure in image enhancement. There is different algorithms are generated. In that algorithms now depends upon our requirement. We have done some modifications on the image. Image means here image pixels, pixel intensities, that is gray level values. So we are going to manipulate, we are going to change the pixel values. So compare with the original image, definitely the processed image is somewhat good in quality. So whenever it is a good in quality, we can say that that image is a enhanced image. So broadly, there is a two types of images, two types of classifications. This image enhancement is broadly is going to be divided into two types. One is a spatial domain, another one is a frequency domain. You see here, the image enhancement approach falls into a broad categories, spatial domain methods and frequency domain methods. You know, spatial domain method means whatever that image is going to be represented. Suppose a simple image, if you see with a 3x3, or if it is a 4x4, or it is a 5x5, or it is a 6x6, or it is a 8x8, or it is a 16x16. So whatever the size, it is depends upon up to you and up to the representation of image. Generally, the image size is going to be represented with a 256 by 256 size. So 256 rows and 256 columns. There is a many number of pixel values, gray level values are there. So whenever the why it is required enhancement, whenever the image is captured, in camera, there may be some fault in camera settings or whatever the dynamic range of that camera, and generally there is some whenever the process of capturing that image, there may be the noise is added, so that image is in poor quality, so we need to improve that image. So that is a spatial domain, means general representation of pixels. Usually it is a 256 by 256. Again, I am saying that each pixel is going to be represented with 1 byte of information. So it requires 8 bits. So whenever it requires 8 bits, what is the maximum gray level value here? What is the maximum gray level value? 2 power 8. So we will get 2 power 8 256. So anyway, we are counting this gray level from 0. So 0 to 254, L minus 1. Suppose if we represent that image with 4 bits, for example, if we represent that image is a 4 bits, so what is the maximum gray level value? 2 power 4, it is a 16. So 0 to 15. If we represent that image with 3 bits, so we are going to get maximum gray level value 8, 0 to 7. So it is depends upon the representation of each pixel. Okay. Now coming for this spatial domain, the term spatial domain refers to the image plane itself, and approaches a category are based on the direct manipulation of pixels of an image. So if we see how we are going to get an enhanced image means we are going to manipulate pixel intensity values directly. It is a one way. We have different methods here, we have different algorithms we have generated. So we are going to see each one. Don't talk, don't discuss. Okay, we are going to see in spatial domain also different mechanisms. Now the meaning of this spatial domain is we are going to change the pixel values directly in a spatial domain pixels. And then if we see in processed image, definitely the pixel intensity values, it may be somewhat brighter or somewhat darker, but some work is going to be done on pixels. It is the one way. Another way is in frequency domain. So we are going to be convert this spatial domain pixels into frequency domain coefficients. So in the whenever if we apply any transform, generally we are going to take this Fourier transform, discrete Fourier transform. So this Fourier transform is converts a spatial domain into frequency domain. All pixels are going to be consideration here. Whenever the transformation, there is a kernel matrix, the kernel is going to be multiplied with these pixel intensity values, and then it is going to be converted into frequency domain. Usually the energy is going to be concentrated on low frequency coefficients. So most of the energy is going to be concentrated on low frequency coefficients. So those coefficients don't have information. That coefficients we are going to be remove, or we are not going to be encode this one. So that is the overall thing. So depends upon the type of the requirement or type of the applications. In frequency domain also, we are going to, after getting the frequency domain coefficients, we are going to manipulate, or going to do some work on this transformed coefficients, and and again we are going to apply inverse Fourier transform, and then we are going to get again the images in spatial domain. So you see the difference. In spatial domain, we are not going to be transformed from one domain to another domain. We are going to modify the pixel values directly. How we are going to modify, we will see. In frequency domain, coming for frequency domain, definitely we need to apply a Fourier transform. Whenever it is a Fourier transform is applied, the concept of Fourier transform is the spatial domain to this is going to be converted a spatial domain to frequency domain. On the coefficients, frequency domain coefficients, we are going to perform some filtering operations. It may be a low pass filter, or maybe a high pass filter, or some Gaussian low pass, or Gaussian high pass, or Butterworth low pass, or Butterworth high pass, whatever it is, depends upon the type of the requirement. We are going to do some modifications, and then output of that transfer function, output of that filter, we are going to be again converted into a spatial domain. Okay, it is the process is going to be involved in frequency domain. Now coming for a spatial domain, how we are going to be modified. Now it is a general representation, a mathematical representation of spatial domain. So you see here a spatial domain process, or otherwise you see, as indicated previous, the term spatial domain refers to the aggregate of pixels composing of image. Spatial domain methods are procedure that operates directly on the pixels. Directly, you see this one, directly on the pixels. So this g of x comma y indicates that it is a processed image. G of x comma y indicates that it is the processed image. F of x comma y is your original image. So this T is operation. What type of operation we are going to be perform on the pixels is going to be represented with this T. Okay, you remember f of x comma y, don't confuse here this mathematical formula. F of x comma y is our input image, g of x comma y is our output image or processed image. T is a transformation operator. This operator T is going to be perform what type of operation? What type of operation we require, we are going to be perform. 1 second. One second. కనెక్ట్ కావట్లేదా ఎవరికన్నా క్లాసు? హలో,
కొంతమంది కనెక్ట్ కావట్లేదు అని చెప్తున్నారు.
ఎందుకు ఇంకా 17 ఉన్నారు కదా? స్ట్రెంత్ తక్కువ ఉన్నారు కదా? మెసేజ్ పెట్టినారు ఎవరు? ఓకే, మీకు వినపడుతుందా? డిజేబుల్ పెట్టేసేసాను. Okay, now this, it is your input image pixel. F of x comma y means it is going to be depends upon this x rows, y column, depends upon the selection of rows and columns. We are going to be manipulate any pixel, that is depends upon the type of the operator. So you see a simple representation of a spatial domain. Now it is, you see here, it is a matrix. It is going to be represented with x rows, y columns here, or x columns. It is x column, y row. Here x represents the column, y represents the row. Now a particular, now here there is a different types of spatial domain techniques. Directly operation, directly one type is a directly we are going to perform. Another type is we are going to take a kernel, or this is called a window, or it is called a mask, or it is called a kernel. So a template, we have different names. So here whatever the operation we are going to be perform on the input image pixels, it is based on ఎవరు మాట్లాడదు, ఎవరు మాట్లాడారు? Don't talk. Okay, okay, now it is going to be consider this mask. So this mask is going to be a filtering mask. It may be averaging, low pass, or it may be high pass, or it may be median. So here it is going to be moved from one, it is going to be scanned row wise, like this, like this, like this, all entire image. So the performance, the operation is going to be performed for each mask. There is a predefined weighted functions are there for a neighboring pixel. So the pixel intensity we are going to be change here, it is depends upon the mask type. So where it is averaging, we are going to see this averaging and median and high pass, how it is going to be seen under this type of one. So it is an image, that image is going to be divided like this, rows and columns, and based on the mask also we are going to do some modifications on the processed image. Okay, now another way of representation, it is a one way of representation. G of x comma y is equal to transformation of f of x comma y. Instead of representing this as x comma y, now we can represent some s is equal to transformation of r. Here what is this r? What is this r? Gray level values in the input image, gray level values. So in our standard image, what are the gray level values? What is the range of gray level values? Any one person? Gray level values, gray level values anta ikkada 8 by మన 256 by 256 image కి our gray level gray monochrome image కి what is the range of these gray levels for input image? ఎంత ఎంతమా? 0 to చెప్పండి, 0 to 255. Okay, so this R indicates that is in the range of 0 to 255. So output image లో ఉన్న గ్రే లెవెల్స్ కూడా వాట్ ఇస్ దిస్ రేంజ్? వాట్ ఇస్ దిస్ రేంజ్? ఈ రేంజ్ ఎంత ఉంటుంది? ఈ రేంజ్ ఎంత ఉంటుందమ్మా? ఇట్ ఈస్ ఆల్సో 0 to 255. And in these gray level values, we are going to perform some operations. It is depends upon the transfer function. So we are going to see the transfer function. So it is this transfer function relates the input image to processed image or input image to output image. Input image means what here? In the image, the pixel values. So the image, the pixel values, it is output image, the pixel values are gray level values. Okay. So you see a simple example, it is a for contrast stretching. You see here, it is the R indicates the gray level values of input image. S indicates the gray level values of output image or processed image. The transfer function between input and output is like this. The transfer function between input and output is like this. If you observe here, the input image, the gray level values up to this, whatever the 0 to up to certain range. So whatever the gray level values we are going to be considered, all gray levels are going to be rounded off to what is this one? One more thing. What is this one? It is a dark portion. We have a, if you write this pixel intensity values, some 0 to 255. Always remember 255 is a white or bright or light. Next 0 dark, black. And similar fashion, if we see on y-axis, in y-axis also, here it is 0 dark, here it is high white. So if you know, if you are getting this idea, what is the dark, what is the light or bright or white. Now if you see some range of pixel values, these are all our pixel values representation. It is in continuous manner. Generally our pixels are not continuous. So 0 1 2 3 4 5 6 like this up to 255. Or for our understanding purpose, if we take a 4 by 4 0 to 15 gray level values for an understanding purpose, instead of representing a 255, depends upon that pixel value. Each pixel value is going to be represented with 4 bits. We are going to get 16 gray levels, so 0 to 15. Similar fashion, a 256 by 256 image, and each pixel is going to be represented with 8 bits. So we are going to get the maximum gray level is a 255. So this range of pixels is going to be compressed to a dark area 0. Similarly, if we see here, up to this range of values, up to this from here to here, and almost high intensity values are going to be compressed to bright pixels, that is white. Now if we see in between this region to this region, there is a slight you see here, there is a slight whenever it is increases, this output is also going to be increases. Okay, it is the a contrast stretching up to some these pixel values are going to be darkened, black చేసాం, ఇవన్నీ ఈ పిక్సెల్స్ అన్ని వైట్ చేసాం. సో ఇవన్నీ వాట్ ఎవర్ దిస్ రేంజ్ ఈజ్ గోయింగ్ టు బి 1-to-1 మ్యాపింగ్. ఇక్కడ ఎలా అయితే ఉన్నాయో ఇక్కడ కూడా అలాగ అవుతుంది. సో గ్రే లెవెల్ పోర్షన్ ఉన్నట్టు యాజ్ ఇట్ ఈస్గా ఇన్పుట్ ఇమేజ్లో అండ్ ప్రాసెస్డ్ ఇమేజ్లో సేమ్ ఉన్నాయి. బట్ వాట్ ఎవర్ ద గ్రే ఆల్మోస్ట్ నియరర్ టు ద డార్క్ పిక్సెల్స్ అంటే లో ఇంటెన్సిటీ వాల్యూస్ all are going to be darkened, and white pixels all are going to be make it is a అంటే dark image is going to be more dark, white image is going to be more dark. It is the one type of transfer function. It is called a contrast stretching. Contrast stretching. So instead of avoiding this confusion, if we consider the transfer function is like this, if you see the transfer function is like this, there is a threshold value we have selected. In this threshold value, m is a threshold value. For example, for our understanding purpose, if we take 127 is a threshold value. Now, whatever the range of pixels 0 to 127, whatever the range of pixels 0 to 127, this 0 to 127 pixels, all this input image pixels, what is the amplitude in the output? What is the amplitude in the output? Fanindra? Fanindra, are you there?
Yes, sir.
What is this output? Ikkada. This range of pixels. ఈ range of pixels output ఎంత? అవుట్పుట్ ఎంత? జీరో అంటే డార్క్ చేసాం, అంటే ఓన్లీ 2 levels. ఇక్కడ ఓన్లీ 2, ఇక్కడైతే we have a different, whenever the transfer function is like this, it allows different gray level values. Whenever it is like this, it allows only 2 levels, either 0 or 1. It is like a binary image. It is like a 0 takes dark, 1 takes white. So it can be converted, whatever the gray level image is going to be converted a black and white image. Whenever the pixel values are less than this m value, less than this m, some 127 or 128, all are going to be converted into black. It is going to be do some work on this image pixels in output. And whenever the pixel values in the input is greater than this m, all are going to be converted into white. So we are going to get a black and white image. Okay, it is the example for contrast stitching. We are going to be black nearer pixels, we are going to be converted completely black. White nearer pixels, we are going to be converted into white pixels. So we are going to get a black and white instead of gray image, we are going to get a pure black and white image. So it is a transformation. Now you see different gray level transformations. We have different gray level transformations. Okay, in this gray level transformation, first one is image negative. Next, log transfer function, log transformation, the logarithmic. Next one is power law transformations. Next one is a piecewise linear transformations. Okay, piecewise, we will see one by one. Now, whenever a linear transformation, if we see a linear transformation, now the relationship with the transfer function, the relationship between input image and output image, how it is, ఈ transfer function ఎలా ఉంది ఇక్కడ? What is this transfer function? ఇది ఎలా ఉంది ఇక్కడ? హలో చెప్పండి అయ్యా, వినపడుతుందా ఫణీంద్ర?
సార్
వినపడుతుందా?
వినపడుతుంది సార్.
ఇది ఎలా ఉంది? ఇది ఇట్ ఈస్ ఏ లీనియర్ మేనర్. సో లీనియర్ మేనర్ మీన్స్ యు సీ జీరో, ఇన్పుట్ ఇమేజ్ లో జీరో ఉంది, వాట్ ఎవర్ ద పిక్సెల్ వాల్యూ ఇన్ ఇన్పుట్ ఇమేజ్ ఇస్ జీరో, అవుట్పుట్ ఈజ్ ఆల్సో జీరో. నౌ ఇన్పుట్ ఈజ్ 127, output is also 127. Input is 255, output is also 255. So there is no any change. It is called a identity transformation. Identity transformation means input pixels and output pixels are going to be same. There is no any change. Input image and output image are same. This is called a linear transformation. Next, negative transformation. Negative transformation means black value is going to be get white value is going to be get black. So this transformation reverse. ఇక్కడ ఏంది 0 0 high. ఇప్పుడు ఏం చేయాలి? We are going to be perform this S is equal to some L minus 1 minus R. What is this L minus 1 here? If you represent any image with the pixel intensity values, the based on the representation of bits, we are going to get the gray levels. Suppose if we represent with 4 bits, we are going to get 16 gray levels. So 16 minus 1, 15. 15 minus all pixel values are going to be in between 0 to 15 ఉంటాయి. Next, suppose if we take with 8 bit, so we are going to get 256 gray levels. So L value is a 256, L minus 1 is a 255. So 255 minus all pixel values we are going to be subtracted. So that is going to be right. This image negative is equal to this S is equal to transformation of R. So the S value is going to be mapped L minus 1 minus R. This, what is this L minus 1? The largest value of gray value, minus these pixel intensity values in input image. If you see this diagram, you will get a better idea. Now it is your input gray levels. R indicates your input gray levels. This Y indicates this S indicates output gray levels. So in x-axis we are representing input gray level values. In y-axis we are representing output gray level values. Okay, so the total range is going to be split into like a 4 parts. Now suppose, for example, for our understanding purpose, L is equal to 16. L is equal to 16. So what is the L minus 1?
15, sir.
Was unable to join. కొంతమంది జాయిన్ అవట్లా, ఎందుకనేట? నేనేమన్నా రిజిక్ట్ పెట్టానా? ఏమన్నా వెయిటింగ్ పెట్టానా? పెట్టలేదు కదా?
వెయిటింగ్ ఉంది సార్ స్టార్టింగ్ లో, మళ్ళీ లేదు.
ఇప్పుడు తీసేసాను. స్ట్రెంత్ ఎంతమంది ఉన్నారు?
70 సార్.
ఉంటాయి కదా, 100 మెంబర్స్ దాకా ఉంది కదా.
ఎస్ సార్.
వాళ్ళు మెసేజ్ పెట్టినారు ఎవరు ఒకరు.
కొంతమంది జాయిన్ అవ్వట్లేదు అని చెప్పి కంటిన్యూగా అడుగుతూనే ఉన్నారు సార్.
ఎందుకనట?
ఏమో తెలియదు సార్, వాళ్ళ యాప్ ఇష్యూనా లేకపోతే
నేనైతే అందరిని అలౌ చేస్తున్నాను.
సార్
సరే, అట్లాంటి వాళ్ళు నేను నోట్ చేసుకోవా.
ఓకే సార్,
చూద్దాం తర్వాత ఏమైనా ఇండివిజువల్ గా పెట్టి వస్తారేమో చూస్తాం. ఓకే, నౌ ఇఫ్ యు సీ హియర్, are you getting? Suppose it is a L value is a 16. Suppose if you represent that image with 4 bits, we are going to get 16 gray levels. So L minus 1 is 15. So అందులో 0 to 3 ఒక రేంజ్, 3 to 8 ఒక రేంజ్, 8 to 12 ఒక రేంజ్, 12 to 15 ఒక రేంజ్. ఇక్కడ మీకు అర్థం కావడానికి. Similarly, the whatever the gray level values in that image is within these limits, 0 to 15 only. Here also 0 to 3, 3 to 5, 3 to 8, and 9 to 12, 13 to 15, like this. It is for simple understanding purpose. Now generally our image is going to be represented with 8 bits. So we are going to get maximum gray level value is 256. That is L minus 1 means 255. So it is some 0 to some L by 4 means some 64, 64 to 128, 128 to around 250 means 60, around 190, like this, or around 200 near, and 200 to this 256. So this is going to be subdivided into 4 parts here. That is the meaning of L by 4. You don't confuse here. L by 4 means the maximum value of L is 256. So based on that we can predict this one. Now you see the relation between input pixels, how we are going to be mapped onto the output pixels. It is the input image pixels. These are the output image pixels. If you see first graph, it is a transfer function. Now this transfer function is a linear transfer function. Is it okay? It is a linear transfer function. So if you see in this linear transfer function, ఇది కనబడుతుందా మనేంద్ర?
yes sir.
So is there any change in this transfer function? If you see 0 0 గా మ్యాప్ చేస్తుంది, L by 4 ని L by 4 గా మ్యాప్ చేస్తుంది, L by 2 ని L by 2 గా మ్యాప్ చేస్తుంది, 3L by 4 ని 3L by 4 గా మ్యాప్ చేస్తుంది, L minus 1 ని L minus 1 గా మ్యాప్ చేస్తుంది. So the transfer function is like this. It is called a identity transfer function. Identity transfer function or linear transfer function. There is no any change in the input image to అవుట్పుట్ ఇమేజ్. అరే ఓకే, ఇక్కడ ఇన్పుట్ ఇమేజ్కి అవుట్పుట్ ఇమేజ్కి ఏమి డిఫరెన్స్ ఉండదు, సేమ్ ఉంటుంది. సో దేర్ ఇస్ నో ఎనీ మాడిఫికేషన్. ఇన్పుట్ ఇమేజ్ చూసి అవుట్పుట్ ఇమేజ్ చూస్తే సేమ్. నౌ ఇంతకుముందే చెప్పా ఏ నెగిటివ్ ఇమేజ్. సో వాట్ ఇస్ దిస్ ఫార్ములా ఫర్ ఇమేజ్ నెగిటివ్? S is equal to L minus 1 minus R. What is the L minus 1 value here? ఇక్కడ మనకి L minus 1 ఎంత? 255.
లార్జెస్ట్ గ్రే లెవెల్.
Largest gray level in the image. Our monochrome image, generally it is L is equal to 256, L minus 1 is a 255. 255 minus R. So, for example, if we substitute R is equal to 0, so 255 minus R, what you will get? ఎంత వస్తుంది? 255 or L minus 1.
255.
ఇక్కడేమో ఇన్పుట్ ఇమేజ్ లో ఏమో బ్లాక్, 0 అంటే ఎంత? బ్లాక్. ఇక్కడేమో L minus 1 అంటే వైట్. ఓకేనా?
White.
సో బ్లాక్ ఈస్ గోయింగ్ టు బి కన్వర్టెడ్ ఇంటూ వైట్. ఇక్కడ L minus 1 అంటే 255. ఇక్కడ అవుట్పుట్లో ఎంత? ఇది అవుట్పుట్లో ఎంత? 0. సో వైట్ ఈస్ గోయింగ్ టు బి కన్వర్టెడ్ ఇంటూ బ్లాక్. సో రిమైనింగ్ ఇన్ బిట్వీన్ 0 to 255, ఇన్ బిట్వీన్ 0 to 255. సో దెర్ ఈజ్ ఏ లీనియర్ ఆపరేషన్కి రివర్స్ ఆపరేషన్ జరుగుతుంది. అంటే లో intensity values are going to be get brighter values, brighter intensity values are going to get lower intensity value. So exactly it is going to be converted a black and white image into white and black image. Are you okay? Black ఉన్న దగ్గర ఏమొస్తుంది? వైట్ వస్తుంది. వైట్ ఉన్న దగ్గర ఏమొస్తుంది? బ్లాక్ వస్తుంది. సో ఇక్కడ లో ఇంటెన్సిటీ వాల్యూస్, ఇక్కడ హై ఇంటెన్సిటీ వాల్యూస్ అవుతాయి. సో ద ట్రాన్స్ఫర్ ఫంక్షన్ ఈస్ లైక్ దిస్. ఇట్ ఈస్ కాల్డ్ a negative transfer function. You see another transfer function, there is a logarithmic curve. There is a logarithmic curve. So it is a anti-logarithmic curve, inverse logarithmic curve. Okay, you see that is that importance of this one also. You see here that example also. Yes, for image negative, S is equal to L minus 1 minus R. Now you know our 8-bit image, the gray level is a 256. So S is equal to 255 minus R. So you see here 0 is going to be mapped to 255, 127 is going to be mapped to 127, 255 is going to be mapped to 0. So black and white is going to be converted white and black. Now next one is a logarithmic transformation. Now the formula for this is also, the logarithmic transformation is also one of